Statistics is all about data, and this chapter focuses on how we actually collect data. So let's first start with some definitions, okay? So a population is the whole set of items that are of interest to us for a particular situation. So for example, let's say that we wanted to collect data on the average age of a person in the UK. In this particular scenario, the population would be every person in the UK. Let's say that we wanted to collect some data on the average size of a deer in a particular species. In this case, the population would be every deer in the species. Let's say that we wanted to collect some data on the most common colour car that is sold by a particular car company in 2024. In this case, our population would be every car sold by the car company in 2024. Just a couple more definitions. If we're talking about a sampling unit, this is one individual unit in the population. Okay, so if we're talking about the population of the UK, one person in that population is a sampling unit. Okay, there's also something called a sampling frame, which is a numbered or named list of all the sampling units in the population. So essentially it's a list of everyone in the population, and they all have either a unique name or a unique number. Now sometimes it's quite easy to get a sampling frame for a population, however sometimes it's quite hard. So for example, if we're talking about people, it's quite easy to get a sampling frame because you can just find the name of every single person, put them in a list, and that would be the sampling frame. However, for example, if we're talking about the example before with the average size of a deer in a particular species, it's quite difficult to get a sampling frame for this, because in order to do this you would have to find every single deer in the species and give them a unique number to make the list and to make the sampling frame. This will be quite difficult. Okay, so there are two types of data collection methods, okay? The first one is a census, where we measure every single sampling unit in a population, okay? So for example, in the UK, we do something every, I think it's about 10 years, called the UK Census, in which every single person in the UK is asked a set of particular questions, okay? This is a census because we ask every single person in the UK, okay? Rather than doing a census where you ask every single person, you can do a sample instead. So what this is you measure some of the sampling units in the population and try to use that data to make observations about the whole population. Now, there are advantages and disadvantages to both of these methods. The big advantage with a census is it should theoretically give a completely accurate result, as you are measuring every sampling unit in the population, okay? If you want the data you're collecting to be 100% accurate, you should do a census, okay? However, they have problems. The biggest one being is they are incredibly time consuming and expensive if the population is large. It's also hard to process that much data. And another disadvantage is if the measurement you're performing on the sampling units is destructive, you cannot use a census, okay? So for example, let's say a company was testing how much force it takes to break a piece of safety equipment, okay? You couldn't do a census on this, because if you tested this on every piece of safety equipment the company made, you wouldn't be left with any safety equipment at the end to sell, because it would all be broken because of the testing. A sample is good because it's much less time consuming and expensive than a census, and there's much less data to process than a census as well. Now, there are obvious disadvantages to a sample, though, the main one being is it will never be as accurate as the census, okay, because you're only measuring some of the sampling units to make observations about the entire population, okay? Another disadvantage is if you have a population that has kind of small subgroups that only make up a small percentage of the entire population. If you're using a particularly small sample, you may miss out those subgroups and they might not be reflected in the data, if that makes sense. The general rule is the bigger you make your sample, the more accurate it will be. Okay, so there are 5 types of sampling methods that you need to know about, okay? So let's start with the 3 types that are random sampling, okay? So for these types of sampling, I'm going to use the same example to show how they work, okay? So let's say that we have a secondary school with 50 students in it, and let's say there are 25 boys and 25 girls, and we want to collect a sample of 10. Okay, now what I'm going to do for all 50 students, I'm going to give them a number like this here, and this is a sampling frame in which we've got a list here and we've given every student a unique number. Okay, so the first type of sampling is simple random sampling, and to do this what we just do is get a random number generator, and then we just generate 10 random numbers, and then whatever student corresponds to that number in this list here is part of the sample. You could instead write the name of every student onto a piece of paper and then put all of these pieces of paper into a hat and then draw out 10 random names. That is also a form of simple random sampling. Now the pros of this is really easy, quick and cheap to do. It's also completely random and free of bias too, because every student here has a completely equal chance of being picked. Okay, there are 2 disadvantages to this method. Okay, firstly, you need a sampling frame. So for example, for this here, you need to give every single student a unique number. In this particular case, that's not that difficult to do, but it might not always be so easy to do that. The second slight disadvantage is for big populations and samples, it can get slightly more difficult because you're going to have to generate quite a lot of numbers, especially if the sample is quite big. Okay, so the second type is systematic sampling, and for this we choose sampling units at regular intervals. Okay, so for our example, we have 50 students and we need a sample of 10. So what we're going to do, we're going to do 50 divided by 10, which is equal to 5. And what this means is the first 5 students here, we're going to pick one at random. We would probably do this using a random number generator, okay? And let's say hypothetically that it gave out 3 like this here. And then we're going to pick every 5th student after this, okay? So we're going to start with 3, and then we're going to pick 8, and then 13, and then 18, and then 23, and then 28, and then 33, then 38, and then 43, and then 48, and this is going to be our sample of 10. Now this method is quick and easy and cheap, and it has an advantage over the first method as it's better for bigger populations and samples, because with the first method you had to generate loads of random numbers if the sample was big, whereas here you only have to generate one random number, which is the 3 at the start here, and then you can get the rest of the sample by just picking the numbers at regular intervals, and it's a lot easier. Now the disadvantages with this method, the first one, again, you need a sampling frame because you need to give all of the students numbers like this here. The other disadvantage, this is a bit difficult to get your head around, is it can introduce bias if the sampling frame is not random. Okay, to represent this, I'm going to pick a different example. Let's not use this example with the students here. Let's say we have a machine that produces equipment, and it produces 50 pieces of equipment, so we're still going to use these numbers here. And let's say hypothetically that every 5th piece of equipment it makes is 40, okay? So the 5th piece of equipment is 40, and then the 10th, and then the 15th, and then the 20th, and then I'm going to indicate that a piece of equipment is 40 using these X's here, okay? If we use our sample from before, where we have this 3 and then 8 and then 13 and then 18 and then so on, we've actually accidentally picked a sample that doesn't contain any of the 40 equipment, and therefore our sample isn't representative. I don't think this is actually too important, this disadvantage, but it is a disadvantage of systematic sampling. The third type is stratified sampling. A potential problem with simple random sampling is it could by chance give me a sample of 6 boys and 4 girls. Let's say I wanted a representative sample, okay? This is what stratified sampling is really good at, where we divide the population into strata, this is just a fancy word for groups, and then we take random samples from them, okay? So you can see the 50 students here, I've split them up into boys and girls, and let's start with the boys. So in our sample, the proportion of boys that we want in our sample, we want it to be the same as the proportion of boys in the overall population, okay? So we have 25 boys here, and then we have 50 students. If we do 25 divided by 50, this is equal to a half. So this is the proportion of boys that make up the population, okay? We want a sample of 10, so we're going to do 10 multiplied by a half, which is equal to 5. So therefore, in our final sample, we want 5 boys. And the way that we would pick these 5 boys is using this group here of 25 boys. We would just use simple random sampling to get 5 random boys. And then we would do the same for girls here, because we also have 25 girls. So we would get 5 random girls, okay? And that would give us our sample of 10. The benefits of this is the sample will accurately reflect the population structure. Another advantage of this method is there's less chance of smaller subgroups being omitted. This isn't really the best example for this because we've only got 2 groups, but if you had a very small group, if you use stratified sampling, there is less chance of that not being included in the sample. Okay, the disadvantages of stratified sampling: you need to divide the population into strata or groups, which could be time consuming, especially if you have a lot of them. And the selection within each stratum, this is just the singular for strata, suffers from the same cons as simple random sampling, because remember, to get the 5 random boys from this 25 here, we use simple random sampling. Now let's move on to non-random sampling, and the first type is quota sampling. I'm not going to use the same example before with the school. Now this is quite common. Let's say there's a researcher that wants to find some data about people, and they want to divide people into different groups, which are called quotas. Quotas could be something like age or gender, but it could also be something more ambiguous like political opinion or lifestyle choices. The size of the quota will be, in the eyes of the researcher, proportional to how many people in the whole population are in that quota, okay? And then this researcher will go out and interview people to see what quota they fit in. Then if they fit into one of the quotas, they'll get certain data from them. If the person doesn't want to be interviewed, or the quota that they're in is already full, their responses will just be ignored. Now this is really quick, easy and cheap. You don't need a sampling frame. You can literally just go out into the public and ask random people and see what quota they fit into. And it also allows you to compare people in different quotas. It has disadvantages though. Firstly, this is non-random, because normally the way the researcher gets people is either by going out on the street and asking them, or sometimes I'll do it by some sort of online advertisement. Either way, this is not random, because certain people might respond to that advertisement, or certain people might be around the area in which the researcher is interviewing, so it's not random. The population is divided into quotas, which if you have a lot of quotas, it could get complicated and expensive. It could also be inaccurate, so as I talked about before, some of the quotas are quite ambiguous and it might be a bit unclear which quota someone fits into. Also, people can just not respond to if they don't want to, and their responses won't be included. And then the final type is opportunity sampling, or it's sometimes called convenience sampling. And you see this type of sampling occurring outside supermarkets or in shopping centres a lot. Opportunity sampling just uses people who are available to be in the sample and are willing to answer the questions that they're being asked. Like it can literally just be people who have gone to a particular shop and have agreed to answer a few questions. This is really easy and cheap to carry out, but it's very non-random and will probably not give you a representative sample of the population. It's also quite dependent on the researcher. They might find a certain type of person more approachable and only talk to them. I just also quickly want to go through types of data, okay? So data can either be quantitative or qualitative, okay? Quantitative data is numerical. I always remember this because it's got quanta at the start, so think about it like quantity, okay? So this is numerical, so for example, it's something like a person's height, it's a number, okay? And qualitative data is non-numerical. So this is something like the colour of a person's eyes, it's not a number, okay? Now, furthermore, quantitative data, so this is numerical data, can be split up into 2 different types, okay? It can either be continuous or it can be discrete. Okay, continuous data can take any value in a range So, for example, if we consider a person's height, this can take any value in a particular range. Obviously, a person can't be 50 meters tall, but within a specific range, it can take any value, okay? So it can be a decimal, it can kind of be however specific you want, okay? However, if you look at something like discrete data, this can only take certain values within a range. So, for example, if you think of the number of children a family can have, it can only be whole numbers. It cannot be a decimal. You cannot have 2.5 children, for example. This is discrete data because within a range, it can only take certain numbers. Discrete data is normally only whole numbers, but not always. Okay, so now I'm just going to go through some exam questions for this topic. They love to ask a lot of 1 and 2 markers for this topic. So we're told here that Charlie is studying the time it takes members of his company to travel to the office. He stands by the door to the office from 8:40 to 8:50 one morning and asks workers as they arrive how long their journey was. So for part A, for 1 mark, we need to state the sampling method Charlie used. Okay, so he's standing by the door, he's standing in an area, and any workers who are arriving, he's asking how long their journey was. So this is an example of opportunity sampling, or you can call it convenience sampling if you prefer. Okay, and then for part B, we need to state and briefly describe an alternative method of non-random sampling Charlie could have used to obtain a sample of 40 workers for 2 marks. So it wants another method of non-random sampling. So the other method of non-random sampling is quota sampling, and this is essentially the exact same thing, except he just needs to split them up into quotas and try and find people to kind of fit into the quotas that he's looking for. So we need to describe an alternative method. So like we need to split it into a quota. So an example for a quota, for to get the mark, you just need to say any type of quota he could have used. So you could use, for example, age. You could use gender. You could use maybe the salary of the workers and see if that affects how long it takes for them to come to the office. Anything like that would give you the 2 marks, okay? And then for part C, we're told that Taruni decided to ask every member of the company the time, X minutes, it takes them to travel to the office. And for part C, we need to state the data selection process Taruni used for 1 mark. So they have asked every member of the company the time it takes. So this is a census. Okay, so here's another exam question where we're told a company sells seeds and claims that 55% of its pea seeds germinate, okay? And then for part A, we need to write down a reason why the company should not justify their claim by testing all of the pea seeds they produce for 1 mark, okay? So if they're testing every single pea seed they produce, by the way, if you don't know what germinate means, it essentially just means when kind of the seed starts to turn into a plant and it's no longer a seed. If they're testing all of the pea seeds they produce, this is an example of a census, and we talked about this as one of the disadvantages of a census. If the testing is destructive, you cannot use a census because you will have nothing left over, and this is an example of this. If you were going to test this claim for all of the pea seeds, that means you would need all of the pea seeds to germinate, and you would need them to kind of start to grow, and then you wouldn't be left with any pea seeds at the end to actually sell. They would all have just kind of grown already. So therefore, because all of the pea seeds would have germinated and you wouldn't have any left to sell. Okay, so here's a final exam question where we're told a sixth form college has 84 students in year 12 and 56 students in year 13, and the head teacher selects a stratified sample of 40 students stratified by year group. For part A, for 3 marks, we need to describe how this sample could be taken. Now, I'll be honest, I think there are a lot of students who wouldn't get all 3 marks here because you need to include quite a few details in order to get all the marks. The first mark is pointing out the fact that you need a sampling frame. And the way that you can do this is for each year group, give each student an individual number. This would give you 1 mark, and this is important to note because if you don't say this, you can't actually do the stratified sampling because you can't do kind of the simple random sampling that you use in order to get the sample of the students in year 12 and year 13, okay? So if we now focus on the stratified sampling, so we have 84 students in year 12 and 56 students in year 13. So let's start with year 12. Okay, so firstly, actually, we have 84 and 56. So 84 plus 56 is equal to 140. So this is the total amount of students. So this is the entire population. Now remember, for stratified sampling, the proportion, we're talking about year 12 here, the proportion of year 12s we want in the sample is going to be the same as the proportion of year 12s in the entire population, okay? There are 84 students in year 12 and 140 students overall. So if we do 84 divided by 140, this is equal to 3 over 5. So this is the proportion of year 12s in the entire sixth form, okay? So therefore, in order to get this proportion in the sample of 40, it's going to be 3 over 5 multiplied by 40, which is equal to 24. So this is the amount of year 12 students we want in the sample. Now let's focus on year 13. So there are 56 students in year 13. So we're going to do 56 divided by the 140, which is equal to 2 over 5. So this is the proportion of students that are in year 13. Therefore 2 over 5 multiplied by 40 is equal to 16. So we want 24 year 12s and 16 year 13s. Okay, so what we're going to say is for year 12, do simple random sampling on the 84 students to get a sample of 24, and this will be the stratified sample here. And then for year 13, do the same, but get a sample of 16 students from the 56. There's 56 students overall in year 13, and this here, because 24 plus 16 is equal to 40, this would give you your sample of 40. So to get the marks here, as I said before, you get 1 mark for talking about that you need a sampling frame and you need to give each student an individual number, and then you get another mark for mentioning simple random sampling in terms of how you actually get out the students from their year groups, and then you get another mark for mentioning 24 and 16 for the stratified samples.